I'm the Dean of the School of Information here, and I'm really delighted to introduce Eric Liu and Paul Duan from Bayes Impact, an organization that I think has a lot in common with and great affinity to what we're doing here at the School of Information and really all over campus these days. Everybody is discovering data science, building data science teams, trying to solve problems using the tools and techniques of data science. Bayes Impact, they'll tell you more about it, but it's a nonprofit organization that deploys data science teams to work with civic and nonprofit organizations in order to solve big social impact challenges. I think there's a lot of potential for our students and our faculty to collaborate with them, and this is partly an opportunity for you to meet them and learn more about what they do and for them to meet some of you. So the way we've organized this afternoon, we have a lot on our agenda. First, we're going to, Paul and Eric will do a brief introduction to Bayes Impact and what they're doing. Then we'll open it up for Q&A. For those of you that are interested in asking questions, we'll provide an opportunity for that. And then after that, directly after that, we're going to break and we're going to put together the panel of 5 women data scientists. This is a rare moment to have 5 women data scientists in one room on the Berkeley campus. So I'm really excited to have that dialogue with them as well. So without any further ado, I'm going to turn this over to Eric and Paul. Welcome. Please join me in welcoming them.
Cool. Hi, everyone. I don't know if this is on. Doesn't look like it. Anyway, so thanks, Anna, for the great introduction. I think we're also very excited to be here. There's kind of like 2 purposes to this meetup. One is obviously encouraging more women to join the data science field, and I think we're all very excited to hear the panel a bit later today. So I'll try to keep it short because that's obviously the main attraction today. But the second thing is we want to kind of raise awareness about the fact that a lot of the problems that you might end up solving in your careers as data scientists or already have solved actually could be very easily ported to solving social impact challenges. And I think we have the chance to live in an age where data science is revolutionizing a lot of processes in the industry. And even more so, it's a field where single individuals with a better algorithm or better data management practices can actually have a huge impact on the company they work at. If you just look at Google, Netflix, Uber, you see that the common point is that even a small change in the performance of an algorithm can have a huge impact on the business. My background was at Eventbrite. I was doing fraud detection, and this is one of the fields where between one version of an algorithm and the next, you can have an order of magnitude improvement in terms of reducing fraud losses, simply by being able to detect more fraudsters with less resources. And so I think the question that I had at that point was, why are we not doing the same thing for social good? I was spending a lot of time volunteering at homeless shelters and food banks at the time, and the main way that you have to volunteer is to just serve a bowl of soup at a time or packaged rice, and none of that is really scalable. It's great. It adds. It's like you add incrementally to the to the operations of the organization you were volunteering for. But how can you unlock the same kind of orders of magnitude improvements that you can get in data science? So I think that's why we created Bayes Impact. And what we try to do is using data science to save lives. The same techniques that we use for predicting demand and reducing wait times for Lyft and Uber rides. Turns out we can use the exact same thing for the day you have a heart attack. You can have ambulances come to you a bit earlier, and I think that's something that we can all agree with is useful. We use data science to reduce poverty. There's a big shift right now in governments towards pay-for-success models, and the question is, how do we even begin to quantify the impact that interventions have on society? How do you understand which factors are able to effectively reduce poverty and which don't? And how do you reward this efficacy? And we use data science to detect disease. So the same way that you can use data science to detect fraudsters, you can also kind of use data science to identify populations that are at risk of Parkinson's or multiple sclerosis. And often you can actually do that ahead of time using the vast amount of data that you have without having to wait for the symptoms to occur and having to undergo expensive tests and so on. So all that sounds pretty great. So why don't we just all do this? I think the problem was whenever you want to do data science at this kind of scale, very often, and I think that's a point that Anna brought up earlier, you're going to end up hitting some governmental roadblocks. You're going to touch upon areas that affect policy. You're going to maybe build algorithms that raise some ethical concerns. And for all these reasons, it's actually very hard to just have a kind of like a hit-and-run approach to doing data science for social good. I think the example I like to give is one of the first projects that brought us to start Base Impact was using data science to inform parole decisions. So if you could accurately predict who is going to reoffend, maybe you could make better decisions as to who should get released on parole or who shouldn't. Obviously, that's a very controversial topic. And even if you do decide that it's a good idea, you still want to make sure that your algorithm isn't biased towards or against a specific part of the population, right? Kind of like a very specific example is in one of the algorithms that is currently in use for risk assessment, sometimes you use features such as the zip code you come from, which makes a lot of sense because maybe you want to look at the neighborhood you're from and kind of like these crime rings, and obviously it's something that is affected by your social network. But kind of the side effect to that is that if you use this algorithm in a city that's very that tends to be kind of like racially segregated, then the zip code is actually a pretty good proxy for race, and that's not something that you want. And the only way to prevent that is to have people who are able to assess the efficacy of the algorithm and make sure that you're not doing something completely stupid, which we very often are. And I think the other problem too is that getting that data in the first place is really can be very hard, right? You have some privacy concerns. Very often the data is in paper format, and even if you end up being able to access that data, being able to implement the results of what you build is extremely challenging. For those of you that have been working at a company, think about how hard it is, even at Google, Eventbrite, Square, all these very modern companies. Think about how hard it is to implement the result of your algorithm. You have to go through all these meetings and present your results and convince the project managers. It's kind of a long and hard process. So think about how hard it is for like a modern tech company, and then imagine how hard it must be for governments and nonprofits. So I think that's why our model is geared towards a heavier engagement model. There's a data kind that I think Catherine is going to talk about earlier that can caters to the other end of the market. So data science volunteers that can solve these one-off projects. And what we're trying to do here is cater to the other end of projects, which is all these problems that require all that preliminary work to gather the data, and also all that follow-up work on implementing the results and assessing your impact and also the policy implications of your work. So we have these 12-month fellowship program that invite leading data scientists to solve big social problems in partnerships with civic and nonprofit organizations. And what we try to do here is to own the entire life cycle of the project, from the inception of the project, so the scoping, the ideation, and also the data gathering, to implementation and the follow-up work. We have this entire pipeline that lasts a year or two, where we have people who are here full time to work on these issues. So our goal is to build decision models. I think you will all agree that data can be used to make better decisions in almost every cases. If you have to make a decision, it's almost always better to have data to back it up than not. But the other thing is that most of the big problems have a decision component to it. If it comes to figuring out who to release on parole, that's a decision problem. If you want to figure out where to preposition the ambulances and fire trucks, that's a decision problem. If you want to make microfinance cheaper by reducing the cost of a microloan, you need to figure out who's going to be a bad payer and who's going to be a good payer, and that's also a decision problem. Our data scientists come from, I guess, these companies and institutions. I think we were pretty surprised that we were able to get such a high caliber of people who were willing to work for a third or a fourth of their current salaries to do social impact work. These are kind of like two examples of our fellows. Usually they've been working in the industry at Google, Nokia for 5 to 10 years. And the pitch to them was actually surprisingly easy. It's actually kind of similar to the pitch that Steve Jobs gave to recruit the VP of Coca-Cola to become the first CEO of Apple. Do you want to keep selling sugary water for the rest of your life, or do you want to come with me and change the world? For us, it's actually pretty similar. We approached Everett and told him, do you want to keep improving ads click-through rates for the rest of your life, or do you want to be the one to build an algorithm that is going to optimize organ transplant allocation and save thousands of lives in the process? It was actually a pretty easy conversation. So we are a pretty new organization. Some of you might have heard about us in the press. So we just graduated from the latest class of Y Combinator. So we've been in operation for about 4 months. We ran a pilot program this summer for 2 months with just 4 fellows. And the preliminary results that we've been able to get were very encouraging. We've been working with Zidisha, which is a global peer-to-peer microfinance institution. And we've reduced fraud losses by 35% with close to no false positive rates. The implications of that are pretty big, meaning that you can actually make microloans cheaper, but not just for Zidisha, but as an asset class. We can easily imagine us going to other microfinance institutions and using the insight that we've gotten through that work and helping them reduce the cost of microloans, because this is the big challenge in microfinance. Is the extremely high loss rates and the extremely high interest rates that they impose on the borrowers. We've been working with the city of San Francisco on building a predictive housing approval tool. I think that one's kind of a good example of a project that's not that sexy, but that actually has a lot of potential for impact. Doing predictive analytics on building permits doesn't sound that attractive, but it's actually a fundamental component to solving the housing crisis. If you're able to figure out which permits are likely to be stuck in limbo, or understanding why they're likely to be rejected, you can proactively take steps and try to remedy that ahead of time so that we can increase our housing supply by, 10, 20%. And the third project we've been working on is with the Michael J. Fox Foundation for Parkinson's disease. We've been mining this huge data set that we've collected. They spent $60 million collecting data on clinical markers, brain scan data, genetic data for 1,000 people. But they haven't had data scientists look at it and try to analyze the data set from a more holistic perspective and try to use data science techniques to find hidden correlations and also trying to find markers that we might not have heard of before. So for that, we've been making great steps towards finding a more accurate and cheaper test for Parkinson's disease. Instead of going through this expensive multi-million-dollar machine that costs $10,000 a run for brain scan imaging, using cheaper ways to assess whether you have Parkinson's. For example, using a smell test, or you can also imagine using a Fitbit to monitor your sleep patterns. And these are all things that we're currently working on. So I think that was it for Base Impact, and I'll let Eric talk about our university program. All right, thank you very much.
Hey guys. Yeah, so thanks, Paul, for the introduction on Base Impact. The part that I'm going to talk about is Base Impact University. So this is a program that we're really excited to launch, actually with the information school at Berkeley as one of the first schools we're working with on how do we get university students that are interested in data science involved in social impact and involved in a lot of these projects. And I guess before I start, how many people are in the iSchool currently? Sweet. So we have an application part at the end, so make sure you check it out. And this will be starting this fall, so you should actually receive an email about Bayes Impact University and the program later in the week or next week. And so hopefully this is pertinent to you guys as you are thinking about what type of projects you guys want to work on over the course of the fall and the spring. So this is the overview of Bayes Impact University. This is how we've structured it for the fall, and this is also a way to get you guys involved in working on many of the same problems that we've noticed across our fellowship over the summer and what Bayes Impact as an organization really focuses on. So over the course of the project, it's integrated with your practicum or your capstone project, and so this is something that you can also incorporate into your thesis towards the end of your program. And you're focusing on one particular social impact project. And the great thing about the projects that we've run is that they go across so many different areas of education, healthcare, criminal justice, disaster recovery. And there's an opportunity for you guys to choose an area that you guys are really interested on. And we've typically found organizations that are kind of leaders in that space, whether it's working with the U.S. government and the technology department there, or FEMA for disaster recovery, or the U.S. Department of Health on a variety of projects. I think these are the ones that we take your work and then transition it into something that will really be used by those organizations. So I think that's a pretty exciting opportunity. In terms of the program itself, it's 2 to 4 students, and there's a selection process as well for each one of these projects. So 2 to 4, depending on the scope of the project, as well in terms of skill sets for the data scientists that will be involved in these projects. There's also an expert mentorship kind of component. So these are a lot of the data scientists, lead data scientists, heads of data science in all the tech companies out here that will be coaching you, on a weekly basis. On one side, great for the networking component, but also great in terms of helping you with some of the applied skills of using, for example, demand modeling with Uber. Right? And one of the projects that we've been working on is a great mentorship opportunity for data scientists at Uber and Lyft to help you guys out on one of these particular projects. And it's also helpful to have folks from the nonprofit space and the government space as well. So this is a tie into the people that spend all their lives really in kind of social impact, right? Whether they're the leaders of a nonprofit or they're leading a government agency. A lot of what we're doing, and this is the last part, is really access to a data science network, but really our network of social impact, kind of socially minded individuals, both in technology and the nonprofit space. So you come out of the program with, one side, a unique experience to do on a weekly basis, mentor with a lot of these kind of folks that are leading different areas in social impact. But you also have an opportunity to, on a more intimate setting with dinners and things like that, to really hang out with these folks. So it's a cool opportunity both on the social impact side and also on the networking side. And I wanted to give you an example of one of the potential projects for this fall so you guys can get a sense of what it would actually look like if you guys were to work on one of these projects. So this one as an example, and we're scoping this one for the fall, but it's all about improving organ allocation with the U.S. Department of Health. And the unique thing about the U.S. Department of Health is that they control on a national level all the organ allocations for the entire nation. And while there are organ donation centers in different geographies, these guys are ultimately making the decision on a federal level. And they want to inform this process by using data science, right? By creating quantitative models in which can help optimize a lot of that allocation. And for the project with them that we're working on is optimizing kidney transplants. And this is the largest waiting list of all the organs that can possibly be donated now. There's about 100,000 people on the wait list at all times for kidneys. And in any given year, in the last year, there are about 30,000 people or kidneys that are able to be transplanted, and yet only 12,000 really get received. So a lot of them get dropped off, the allocation is inefficient, and a lot of times the analysis hasn't been done on this, right? And the great thing about this project is really the data is all there. So there's an organization called the Organ Procurement and Transplant Network that has been collecting data since 1987 on the entire kind of transplant process, from the individual patients to the organs that are available to the quality of the organs, location of the organs as well. So it's an interesting data problem in the sense that there's great data available, but there's also a really big need for that. And if we look at the particular project, of course, it's building an allocation model, but what does that mean, right? Like, how is that integrated into what they do? And so the really awesome kind of component of building this model is that it'll be implemented in what's called their simulation allocation models, which are used in the decision process to actually give people kidneys. And that's where the impact that what we are able to do in over the course of the Bayes Impact University program is really being able to inform that type of action on the organization side. So while I also think it's a great thesis kind of paper to write about, if it's something that you produce, actual result, it's something that will be implemented on a federal level with an organization that determines really if a person should live or not. So those are some of the projects that we've been working on for scoping for Bayes Impact University this fall. And this just gives you a sense of some of the organizations we're also working with, and we're scoping for some of the projects for Bayes Impact University this fall. And as you can see, it's pretty diverse. Axion is the largest microlender in the world, and developing fraud detection models for them. FEMA is disaster recovery on a federal level as well. So that project is involved in impact assessment for hurricanes in Florida. And this is a project that also influences policy, building codes that impact billions of dollars of potential damage, and also thousands of lives potentially saved, and education as well. So we're working with charter schools and UC Riverside on identifying students that are at risk of dropout, right? And this is interesting because when you have an ability to take predictive modeling and identify at-risk populations, that's a really unique thing when students are going into schools really to try to figure out how to graduate. And I think that's the interesting part. And the thing that underlies a lot of our projects is how to use data science to help these organizations make better decisions. And I think there's some really interesting projects for the fall. And then in terms of applications, so how does the program work? When does it start? The first step is the online application. You guys should receive this if you're in the iSchool in your inbox quite soon. And it's a short application, but I think it's one thing where you can demonstrate some of your prior experience, and also your interest in social impact. And of course, it's not something where we absolutely require that you have a whole bunch of data science experience. Of course, you guys are in school, so there's something to that as well. But it is something where you show some of your passion for social impact work, and you have the kind of intuitive technical chops for working on these projects. And then the second part is interviews, right? So both technical and behavioral. And then the third part is project selection, which is the really exciting part. So if you guys are part of this organization, what you guys are able to do is pick out areas that you guys are interested in. So we'll give you a selection of projects as well. And if there's one that you're particularly interested in, we also match you with folks that have similar interests. And I think it's one thing where you get to grow with your community, right, the group that you're working with, but also you get to learn a lot more and dig deeper over the course of 6 to 10 months, essentially, on that specific area. So that's pretty much it. That's Bayes Impact University, and would love to answer any questions you guys have.
Great. Thanks so much, Eric.
Yeah, I'm just curious about the university, but also Bayes Impact more generally. Like, how do you pick project partners and the actual projects you work on? Like, what's the criteria? How do you figure out what's most important to work on, given that there's a lot of need and obviously not enough people?
Yeah, it's both an art and a science. I think it's something where we've identified an area of impact, right? And actually, the organ allocation problem is actually one that shows this really well, where organ allocation, organ donation is a huge problem. And for us, how do we apply data science? We know that it's pretty well measured, especially at a federal level. So what we do is we find project partners that then, on one side, have the data, but also the mandate to actually make impact. Like, this is something they want, right? And in a lot of cases, these are our users, right? These are our users of our projects and of our work. And so I think that's really it, right? It's like finding social problems, finding data science problems as well, and marrying those two. And as much as I would like to say that it's a process where you just go online and search somewhere, it's not quite that. I think there's a lot of kind of research and work that goes into it.
Other questions?
Do you guys have or plan to have any partnerships with educational institutions?
Yeah.
I mean,
in fact,
for data science for better education or things like that.
Yeah. So in particular with UC Riverside, that's a project we're going to be working on this fall. And this one is all about assessing student outcomes. So we're finding 8 factors. We want to identify particularly 8 factors, build a correlational model on top of that to then say which are the students that are performing really well, which ones are not, and why, right? And I think this one, with Riverside in particular, about a third of their students don't graduate within 6 years. And so the point is, can we build models for them? And probably a little bit different than Berkeley, but I think it's something where with Riverside in particular, it's been a big problem for them. And they have all the data there as well, and it's a matter of like how can we make actionable things out of this data to improve graduation rates.
Can you say something about the statistical and other kinds of? Thank you. Thanks, Anno. Can you say something about the statistical and other kinds of mathematical models that you're looking for? Because the organ issue, I assume, is some kind of optimization model, but maybe not. It could be linear programming. It could be something more sophisticated. You've just described something that was more of an inference problem where you're looking through data and trying to predict certain things. So what are you looking for? What kinds of problems are you trying to solve?
So for us, there's actually a pretty wide range of problems that we're trying to solve. Sometimes the problem is just in the data management policies. They just don't have great procedures for acquiring that data. That's kind of like in the case for FEMA. And I just realized I'm on the record, so I'm sorry. And in some other cases, for example, for the city of San Francisco, we are currently scoping a project for optimizing ambulance dispatch. And there are several pieces to that. One of them is simply creating a demand prediction model, so being able to figure out where demand is likely to arise. But other ones are more, in terms of mathematical optimization. How do you make sure that you can always cover these areas where there's a high risk for some super emergency that you'll need to get to in 5 minutes or less, while being able to still optimize the rest of the network. And it can also range from a more just purely programmatic point of view is how do you create how do you pull the data to be able to create a map of driving distance versus driving time, right? So if you look at the map of San Francisco, you can pretty easily figure out what's the distance between 2 points. But obviously, but the big question is that ambulances don't have to abide by the same traffic laws as other vehicles, so it's actually not such a trivial problem to figure out how to translate that into a driving time problem. So there's a wide. I think that project is kind of a good example of one of these projects where there are several different pieces to it. So it's I guess it's kind of a non-answer, but we try to get fellows who can cover all these bases. Yeah.
You mentioned earlier one of the projects sort of had this controversial element, and I'm curious how you guys have approached dealing with that kind of controversy, like building bias into whatever models you're using. It's probably hard to help. You can't get the bias out, but what have you done to deal with that problem?
So the biggest one is just simply scoping a smaller project that has the same components to it, but might not be as controversial. In that case, it turns out that if you just want to use the risk assessment algorithm to simply better match the parolees with the best possible parole officers, you can have a way to reduce crime and recidivism by matching the higher risk people with the most experienced parole officers. And in that case, you're not releasing anyone who would not have been released otherwise, and you're not preventing anyone from being released either. You're just making that matching more efficient and reducing hopefully reducing crime overall just by this simple change. And once you can prove that this works, and you can have a few more data points to make sure that there's nothing weird at play, you can start doing some smaller pilots at the county level before blowing it up to the entire state level or federal level.
Great. Okay, I think this has been fascinating.
Yeah.
I want to thank Eric and Paul.
Right.
Now we're going to take a 3 to 4 minute break. their networking capabilities are evident in the fact that they brought us 5 women data scientists. We're going to ask the women to come up onto the panel, and we're going to talk a bit about women in data science and what that's all about. So thanks again for your great presentation.
Thank you.